Right, we're looking at May 2018 question 3, part B. First part there, we're looking at confidence intervals. In this case, we have train times. We have 16 train times, right, in minutes. And we're assuming that the train times for this particular commute follow an approximately normal distribution. Part 1, determine the 95% confidence interval for the mean commute time mu, right? So we need to figure out which formula we're going to use here, and because we've less than 30 of these, that's important, right? So I'm going to go to the back of the exam paper, and we've less than 30. See, greater than 30, forget them ones, right? Forget that one there, because that applies when you have a sample size bigger than 30. And here's mu, confidence interval for mu when n is less than 30. So that's the one we're going to use, and both sides are quite similar except for the plus and minus here. We need x bar, which is the average sample, the average of the samples, right? 16 of them, so we get the average value. And s hat is the sample standard deviation, and we're going to use the calculator to get x bar and s hat. So I'm just going to write down that formula there first. So it's x bar minus t, we'll be using t tables to get t values as well, s hat root n, so mu is bigger than that and is less than x bar plus that same structure there, the t value times s hat over root n. So now we're going to bring in the old calculator, and we're going to enter in, how are we going to do that now? We're going to enter in our 16 values. So I'll go back to page 3. There we go. And just move that over here now. See. And here's my calculator. So I'm going to enter in the 16 values. So I'm going to go stat mode. This is the new Casio calculator. So go menu and scroll rightwards there to that and press equals. And now we're going to go with number 1 there, one variable or single variable, because we only have times, that's it. There's no x and y, there's just one of each, right? So we go 1 there, and now we enter in our values there, 29.3, and the next one is 28.4, and then we have 27.5, and so on. 26.8. Just pause now when I do this. So now I've entered in all my 16 values. Hopefully I have them all in correctly. You know, I could scroll back up there, 29.2, 30.3, 30.1, you know, check them. 26.1, 28.3, is that right? 28.3. And then we have 32.5, 31.4, etc. So it looks good. Now I can press the on key. They're still stored in the calculator. And now to get summary of all those, I press the option key and number 2 there for single variable calculations, number 2. And you see what comes out on the screen there now. I'll zoom in a bit there. And you can see that we have x bar is 29.106. X bar is 29.106, and we're looking for s of x. So we scroll down one screen, and we get s of x equals 1.73. They're the two figures we're looking for there. Again, we've x bar 29.1 and a bit, and then we've s of x. That's our s hat. So I'm going to write the two of them in there. Take a note of them. So I have x bar from the calculator, x bar equals 29.10625, and s hat, which on the calculator was s of x, right? It was on the calculator s of x. S hat is what? 1.731. So that leaves us now, we have this bit, we have root n is just going to be 4 because n equals 16. There's 16 values. So root n equals 4. And then we have, what we have to do? We have to get our t value. So how are we going to get our t value? Well, our t value, we have to look up the t tables. So we need our degrees of freedom. And our degrees of freedom, DOF, will be equal to n minus 1, which is 16 minus 1. And that's 15. So we have 15 degrees of freedom to look up for our t values. So to look up our t value, before we look up our t value, look, we look at this here. Look, we're looking for a 95% confidence interval. So that's important. 95%. So we'll bear that in mind when we go down to the back of the exam paper now. We're looking page 20, somewhere around there. Maybe up one. And this is our page. Up again. And again, yeah. So here we have our t tables. And remember, 95%. Degrees of freedom down to 15. So we're looking across this row. So now we just have to make a decision. 95%. We have a two-tailed test at 95%. So that leaves us with 5% either side of the curve. So we think about something like this. We'll have some kind of curve, and in the middle here is 95%, which is the same as 0.95. So that leaves us with 0.05 to be spread between the two tails. Okay, so 0.05 to be spread between the two tails. Divide that by 2, and you get 0.025. So this guy here, 0.025, and this guy here, 0.025. So back to the tables, and look, we have a two-tailed test, 5%, and if it was one tail, it'd be 2.5%. Anyway, we go down here, and we're taking 2.131 as our t value. 2.131. So our t value with 15 degrees of freedom, it was 2.131. So now we have all the bits to fill in our formula. So x bar here is 29.10625 minus our t value 2.131 multiplied by s hat 1.731 over root n or root 16. That's just going to be 4. So mu is going to be bigger than that and less than 29.10625 plus the same structure, right? 1.731 over root 16. So we just need to tidy that up. We'll tidy that up, and we'll get mu is greater than 29.0138, and mu is less than 29.922. So just put all the stuff from each side into the calculator, and this is what you should come out with. So we can say we are 95% confident that the population mean lies between those two values, lies between 29.0138 and 29.922. and what are we talking about here? Back, I think it's just minutes, isn't it? I'll just go back up here, 3, just to be sure. Waiting times in minutes, right? So it's nice to put in the units always. So we're 95% confident that the population mean lies between those two values.